Next, we are going to see chapter 5, fans and blowers. Fans, blower. Chapter 3, what we discuss, compressor. What is the difference between fan, blower, and compressor? Fan, blower, and compressor.
Refrigerant is used in compressor.
Compressor. It's a compressor means it increase the pressure. Understood, na? Compressor, it increase the pressure. Any doubt? Compressor,
No.
it increase the pressure. And fan and blowers, fan blower, what is going to do? Fan and blowers.
Low circulation, air circulation.
Air circulation. Fan is also low pressure. Fan, low pressure, little bit increase the pressure. Blower increase the pressure and the force also. This you understand, na? Basic. Okay, here very important basic. We are this chapter we are going to discuss main important points related to formula, how to calculate everything easily. Then finally we are going to discuss all the theory part. Very important points. The chapter 5 basically cover fan types. What are the fan types? Already we discussed compressor also. What are the types and parameters? Same, everything same only. Fan characteristics or performance. Here very important one is a fan law. Okay, very important. This is you have to remember this fan law. We are using throughout all the chapter. 1 mark, 5 mark, 10 mark, and energy auditing also the fan law they are using. Same factor operating efficiency, design and selection, pressure drop, system resistance, flow control strategy, performance assessment. Every equipment have the energy saving opportunity. This is always coming 1 mark. Here I see the specific ratio, very important. Specific ratio. So what is the specific ratio? It's a outside daily discharge pressure over the suction pressure. Specific ratio equal to here is a fan and everything blower. This is a discharge. Here is a discharge. Here is a suction. Okay. Here is a pressure measuring. PD. Suction pressure PS. Specific ratio equal to discharge pressure divided by suction pressure. Here suction pressure means natural. Okay, natural pressure. In discharge pressure will increase now. So always greater than 1. Understand? This point understood now? This is a specific ratio. Very important 1 mark. The specific ratio, the ratio of the discharge pressure over the suction pressure, is used for defining the fan or blower or compressor. Very important. The fan up to 1.1, little bit increase the pressure. Blowers 1.1 to 1.2. Okay, maximum 1.2 increase. Then compressor more than 1.2. Very important. If more than 1.2, this is a compressor. Main function is fan, blower, provide ventilation, industrial process equipment they are using. And fan and blower selection depends on the volume. Very important volume. Volume flow rate, pressure, type of material handle, space limitation, efficiency. Here you see now, this is volume. How much volume they require? fan and blower, everything. And flow rate depends. And the type, very important, two category. One is a centrifugal, another is axial flow. The centrifugal, this is centrifugal. Here you see, this is a centrifugal fan. Air incoming one direction, outgoing other direction. Axial flow, same direction. Same. Axial flow going same direction. There is no change. Air going, incoming and outgoing. But centrifugal fan, two direction. Very, very important note. One, when entering the one direction, leaving another direction. Here forward, backward, inclined. Axial flow, enter the and enter, leave, same. There is no change direction. The propeller, tube axle, fan axle. The types we will discuss later deeply. Only you have to understand this forward. Forward means sometimes they will give the some diagram, which is a forward, which is a backward. You can see that this is a forward, this is a bend. Here you bend, na, this is a forward. Suppose bend is a here opposite. You have always remember clockwise. This bend is a anti-clockwise. This is a backward. Here straight. It's a radial. It's a paddle. Okay, this understand, na? The basic, the centrifugal fan, axial fan, two types. This is a centrifugal fan, two types. Two times change the direction, axial flow, no direction. Here I rather one diagram. You have to tell me what are the basic unit concept we have to take. Here fan, air incoming. Here air incoming. Suck. Okay. It's a discharge. The system resistance. This is a fan. This is a fan. The system resistance, pipeline, bending, plants, everything depends. Okay. The airflow is a basic unit. What are the things we have to quantity? That means we are taking the power. Power means VI cos phi. You understand? Power means VI cos phi. Same. What are the units we have to take it? Flow. What is the flow? Here. Here we taking flow now. Airflow. Always going airflow. Can you understand? You can easily remember the formula. Here flow. Airflow going na here. Flow. Velocity. Flow velocity.
Area.
Flow velocity. Next one. Pressure.
Area.
Pressure. Yes.
Pressure volume.
Pressure. The pipeline diameter, area. Okay. We took this one, this pipeline. Next one, fan. We are going to take fan. This fan depends. What is it depends? The fan. Fan speed, na? Fan speed. Speed.
Power
Next.
consumption.
Yeah, fan, power consumption. Fan, speed and plate, na? Plate size. Dia. Power consumption. Here delivery pressure. Here discharge pressure. Here suction pressure. Same airflow, same like this. Here suction pressure. This is a basic unit. Okay. Can you understand this basic unit? What are the same? Flow, velocity, pressure, diameter, the pipeline diameter, area. Area means pi r square. Same, you have to remember. The fan means it's a speed. Speed means N. And power consumption. Okay, this is a fan, and before you have to remember the speed. The speed, everything. If speed increase, what will happen? Speed increase, what will happen?
Velocity increase. Output. Discharge pressure.
Speed increase, what will happen? Power increase, same velocity increase. Next.
Discharge pressure increase.
Pressure increase. Velocity, pressure, and power.
Bus.
Yes, bus na. This we have to relate it. This speed is common. Always keep it. Speed is common. Common means all the equation you have to keep it speed. Okay. This is very one thing you have to understand. Flow. What is the flow? This is the flow, na? Here, flow. This also we have to include flow also. Speed increase, flow increase. Understood? Speed increase, flow increase. So next, the speed directly proportional to flow. That means flow directly proportional to speed. This understood? Flow directly proportional to speed. You can see the diagram na? Here. Flow, speed. Speed, draw the diagram. Whatever. If speed is 1000, same directly proportional to flow. There is no change. And next is a pressure. Static pressure. This means static pressure. Directly proportional to speed square. Understand? Pressure directly proportional to speed square. That means static pressure. Directly proportional to speed square. When speed square term increase, pressure also increase. Static pressure also increase. But it's a square time. Very important. Next is a power. Power directly proportional to speed cube. Always remember.
What is N, sir? N?
N means speed. RPM.
N means speed.
N means RPM. Revolution per minute. Motor
N
speed.
SP?
Fan
SP?
speed. SP static pressure. SP static pressure. That means total pressure. Static pressure. Very important. Not total pressure, it's static pressure. SP. SP means static pressure. Next is power. The fan consumes power, na? Power directly proportional to N cube. Understood? The N cube. How to relate this one? Very important. Here n square, n cube, na? Okay. Otherwise, simply you can remember n cube, n square, n. How to relate this? N cube. Here fan. First you start with a fan. Fan. Here take power, na? Here take power, na? Fan. Here take power. Fan always take power. Here n. Fan node speed always common. So power. That means cube. Power cube. Always remember power cube. Starting. Then next step. Then airflow. Here airflow. Here create static pressure. Here create the pressure. Then n cube going to reduce one going to one top near this one. Then what will happen? N square. 1 by 1 reduce. You have to understand this like this. Static pressure. Then finally flow. Here is a outgoing flow. Can you understand? First one is a power. Next one is a pressure. Here pressure drop between how much pressure? Here normal flow. The flow Q. Here n cube. 1 is reduced going to n square. Then 1 going to reduce. Then n finally. Can you understand this one? You can easily remember this one? Not?
No.
No, na? Okay, 1 second. Just fan rotating speed. You have understand? Fan. You have to always take it. Fan. What are the main incoming? Fan incoming power. Fan incoming and outgoing. You have to take fan incoming, fan outgoing. Incoming two types, air income and power income. Power, air. The fan always speed. You always remember speed, N. You remember the always fan is a speed. Speed is a common. Whenever fan rotating, here airflow going. Airflow. Airflow going, na? You can understand airflow. When airflow going, that airflow always going the duct, it create a pressure. You can understand this 3 point. You can remember fan basic concept. Fan is creating speed, then airflow, then pressure creating in duct. You can understand this one, airflow, pressure. Any doubt?
No.
Okay. Then for fan, what are the incoming available? Air incoming. This is a basic air incoming. Next one is a power. Next one is a power. Next one is a power. Power always remember, power means power cube. This is a basic formula, all the fan and blower you are using. Power means power cube. Power cube. Always remember this one, power cube. Once you remember this power cube, N power cube. Then next step going, what is going? Pressure. Okay, fan creating pressure. N pressure square, static pressure square. Then finally, what you receiving here? After finally, what you receiving here? Down, final flow, na? How much? When you switch on the fan, motor, the fan taking power. First, fan taking power. That means power cube. Then fan rotates speed. Then it create a pressure. Then create any pressure difference. Then only the air flow comes to you. Can you imagine? This ceiling fan. This ceiling fan. When you put it switch, then fan rotate. Whenever switch foot, what will take it? Fan take it, power take it. Then fan rotating, na? Fan how to rotating? Any pressure difference between the fan rotating, it create a pressure difference. Then pressure. Then airflow. Can you imagine? It is possible to imagine. When you are going to switch on your fan, what will happen? First take it power. That means power cube. Then fan rotate. The rated speed. Rated speed. Then what will happen? Pressure created. Rotating, that time pressure created. Then air flow. You receiving the air flow. You feel the air flow to on you. This, can you imagine this one?
Yes.
Okay, you imagine this one. Basic, you have to imagine. You have to remember this formula like this. Okay, whenever you're going to switch on, so fan power consume, then power cube, n directly proportional to power cube. Then what will happen? Pressure create, fan rotate, it will create pressure. Then speed, static pressure square equal to n square. Then finally airflow. You feel the airflow, then equal to n. This is basic formula. Okay, next one is a whenever flow going, na, here duct, everything available. The system resistance, this is a system resistance. Duct, fan, duct, the system resistance directly proportional to flow square. Very important. 1 mark. System resistance directly proportional to flow square. You have to understand basically when we are taking the theory, we can easily clear all the doubts. This basic formula. The basic, why this formula we are using? Why we have to use this formula? Anyone? Why we are using this formula? Anyone guess? The basic guessing is we need to replace, compare with the old one to new one. This is the old one, old fan. Next one is a new fan. The old fan, this is a new fan. Understand? Old fan, new fan, understand? Old fan, new fan, understand? The old fan also have flow, speed, static pressure 1, N1, static pressure 1. What will happen as power 1? Can you understand? Same. New fan also have, we can Q2, N2, static pressure 2, and power 2. Is it possible to understand? Both we need to compare. This understand? This understand, na? Both need to compare. With general formula, what is the general formula? Q directly proportional to N, static pressure directly proportional to N square, power directly proportional to N cube. N cube. Okay, this general formula used for this two fan. Compare. Okay, to calculate. You have to imagine. Okay, fan new. That means you improve the pressure or improve the speed, improve the flow. What is how to equal two formula for two fans, two system. For two fan or improving the operation. Same fan. For example, now fan is running 1400 speed. Okay. 1400 RPM. Now I am going to increase the speed 1500 RPM. Can you imagine this one? Now one fan running is a 1400 RPM. Now increase the speed is a 1500 RPM. This flow is a how much flow? Just imagine. Flow is a 600. What will happen for this one? Can you calculate easily? Flow is a 600 meter cube per hour. What is this new speed? How to equal this one?
Directly proportional.
Okay. 1000. The next you have to write it 1000 because 600 means you can tell only 600. Understood, na? This
Flow
is
is
the
directly
speed.
proportional to speed.
1400 directly proportional to 600. Next, 1500 directly proportional to x value. Then I need to find out this x value. So x I keep it. Then x going to top side. Then 500 going to here, cross 600 into 1500 divided by 1400. Can you calculate this one? Now understand, na? X going to here. 500 going to here. You can write it like this also. N1 divided by N2. Okay. Directly proportional means, so flow Q1 divided by Q2. Can you understand this one? What is the N1? What is the N1? What is the Q1? Q1 is a 600, na? Q2 we don't know. N1, what is the N1? 1400. Q2 is 1500. Now can you imagine this one? Now tell me the value quickly. Any doubt? Tell me. Any doubt? Any doubt? Ask me. Quickly done. 600 into Q2 how much?
Equal to
642, na?
0.85.
642. Okay, meter cube per hour or second. Okay, this is you understand, na? Okay, same flow is a power. Power is a same speed, power. Here, write it. I will write it. 1400 RPM, power is a 90 kilowatt. Okay. For 1500, what is the power? Power 2. How to calculate? How to calculate? Write it formula. What is the formula? P1 divided by P2 equal to N1 divided by N2. What is the cube, na? We can write it like this also. N1 cube, N2 cube. Can you understand this one? Quickly tell me, na? This is understand, na? Can you understand this one? Any doubt? Nilesh? Power, here power on 90 kilowatt. Power 2 we need to find out. N on how much? 1400. N2 1500. This is a whole cube. Nilesh, Vijay?
Yes, sir.
You are doing calculation? Next, P2 equal to, what is the P2 equal to? How to calculate P2 equal to?
P2 is equal to 1500 into 90.
500 cube. Understand?
Cube.
Cube into 90 divided by
1500.
cube.
400.
Okay, now tell me the value.
Into 90. 110.69.
110.69 kilowatt. If you are easily remember this formula, very quickly remember this formula, always they asking P2 or N2, second stage, always improving. You can write it formula direct way. How to write direct way? P2 divided by P1, na? Always we know we want to find out P2. So P2 directly proportional to what is the value? P2 power cube. Tell me. N2 cube, N1 cube, na? Understand? Anyone, any doubt? No? I take no. Why is not clear? Others, Vijay?
Okay. Understand.
Okay, na? This understood, na?
Yes.
Because you can ulta, because we are confusing multiplication. So the straight away we have to write it P2 divided by P1, N2 cube divided by N1 cube. Then we can easily find out P2. Okay? Directly, straight away. Same keep it N2 divided by N1 cube. Only multiply into P1. This finish? This okay? This
Yes,
okay,
yes.
na? You have to rearrange the formula, every formula like this. For understanding purpose, you have to understand everything. Q2, 1, you know, N2 divided by N1. Static pressure 2 divided by static pressure 2, because directly proportional to N2 square divided by N1 square. Here power 2 divided by power 1, N2 divided by N3, N1. What will happen? N cube. Okay. Next time giving one calculation, you have to do it, na? Static pressure, same speed. Okay, same speed. Static pressure 170 mm water coolant. Static pressure 2, you have to find out. Okay, quickly find it. Tell me.
N is not given. What is N? Punchard. N कुठे याच्यामध्ये N पाहिजे ना त्याला स्पीड विदाउट स्पीड कसं
घ्यायची
कॅल्क्युलेट करणार स्टॅटिक प्रेशर
1400 1500
1500 का
N1 N2 N1 1400 N2 1500
ओके ओके
Okay, done. How much coming value? You always remember speed increase, value also increase. Speed reduce, value also reduce. If speed increase is a 70, next pressure greater than 70. What is the value? Tell me quickly. Still finding.
$80.35
8135.
80.35
Okay, this is square, na? Okay, 8535. Stress P2 equal to 8135 mm water coulomb. Okay. Okay, next. This is very important 1 mark. Sometimes always they asking here speed 1500. I am going to reduce 10%. 10% means what is the value? 1500 reduce 10%. How much value?
1350
1500 10%. How much value reduce?
150
150, na? Okay. 150. If I am going to reduce 10%, flow how much percentage reduce?
same directly proportional na
Yes. How much percentage flow?
निकल लो ना Q1 Q2 is equal to N2
Yes.
by
Percentage. If they ask me percentage. If I ask me the percentage.
10% only.
10% only, na?
directly
Okay.
proportional
How to calculate 10% increase? If 10% increase means what will happen? Flow. Speed. Speed 10% increase.
flow will increase
Flow will increase, na? How much percentage?
10%.
10%. How to calculate this one? Simple. N1 is N1 equal to. Okay. N2 10% increase. So original value is a N1. So 10% means 1.1 times of N1. Na? Understand this one?
Yes.
N2 equal to 1.1%. Then you have to put it the value in equations. Same Q2 divided by Q1. N2. N2 what is the value? 1.1 N1 divided by N1. There is no difference. So N1 cancel, N1 cancel. Next, Q2 equal to 1.1 Q1. So 1 into 100, 1.1 into 100, what will happen? 1010. This you understand, na? Then 10% increase. Now you understand? 10% increase, na? Q2 equal to 1.1%. 1.1 times Q1. Vikram, tell me, any doubt? Nilesh, Adas, Vijay? Now clear? Okay, next degrees.
Yeah.
Okay, next degrees means what will happen? Degrees. N1 equal to N1, original value. N2 equal to 0.9. N1, na? Please understand? N2. N1 is a N1. So N2 is a 10% degrees means 0.9. 90% of N1, na? They will not give the value, only give the 10% increase, 10% degrees. What is the value of flow? They will ask. Any doubt? Tell me, otherwise, no. Then I will continue. Na?
Can you please repeat this? N2.
Okay. That you have to tell, ask. No? Next is a 10% degrees. 10% degrees speed. Original, this is a original. N1 equal to N1. Next, reduce. N2 equal to 10% degrees. 10% degrees means from original value to new value 10% degrees. What is the value? If suppose 100% N1. Okay, 100% N1. N2 10% degrees. What is the value? 90% N1. Na? This you understand? The hints, everything is highlighted. They will ask the question, speed, if you are going to increase the speed 10%, what is the value of flow? How much percentage increase? They will write like this only. So don't get confused. They will not give the value, nothing. Only the increase, 10% increase or 10% decrease. Now, okay? Okay or not? Quickly tell me now. Nilesh?
Yes, sir.
Understood or not? Otherwise, I will
Yes,
try other way.
No.
Okay,
Okay.
na? Okay. Only the question they ask, the question, everything highlighted. Speed increase 10%. What is the flow, power, pressure? They will ask like this. Understand? Then you imagine. Then imagine, don't put any value. So those, then you have to imagine, okay, now speed going to increase 10%. That means original value is N1. Next, what will happen? Speed other value increase, N2 equal to 110% of N1. You have to imagine everything. Next step, N2 equal to 110% of N1. That means N1, for example, 1500. 10% increase. What will happen N2? N2 how much value?
1650.
1650 na? 1650. Okay. 1650, how much value of N1? 1650 divided by 150. You multiply, na? You divide by how much value? 1650 divided by 1500. 1.1 times, na? N2 equal to 1.1 times of N1, na? Understand?
Right.
1.1 times of N1. N1 value how much? 1500. 1500 into 1.1 multiply, how much value coming? 1.1 into 1500. Quickly tell me.
One 1650.
Same, na?
Huh.
Okay. But they're not giving the value. Please understand, they're not giving the value. Only that they're asking speed increase, degrees. So you have to imagine. So you have to keep it some number. No need number, some identification. Original speed. Original speed is n known.
N1.
N known. Original speed is n known. Final speed n known times of. Okay, n known times of how much? 90% or n known times. Sometime he says they will ask 90% means 0.9 n known. This means n2. Otherwise, sometimes they will ask 110% per 1.1 times n known. This is a basic you have to understand. Once we are doing the calculation, you can easily understand. Okay. Now clear this one.
Yes, sir.
Speed increase, flow increase. Speed 10% increase, flow 10% increase. Speed 10% decrease, flow 10% decrease. This is a basic concept. You understand? Next, it's a pressure. Pressure directly proportional to n square. Suppose everything they ask 10% decrease or 10% increase. What will happen? For pressure, speed 10% increase. I am asking 1%. Vikram, tell me 10% increase. How to write it? How I write it? Speed 10% increase. First you write it formula. Tell me the formula for pressure, static pressure. Formula.
N2 by N1.
Then... Basic formula. You tell me the basic formula.
Basic formula?
Yes, fan law. This is the fan law. We already discussed static pressure. This formula I am asking. One static pressure, two. Okay. N2 divided by N1. N2 divided by N1. This is square, na? Always remember. You understand? This square. Okay, N1 equal to N1. N2 what will N2 value what is 10% increase. Then 1.1 times of N1, na? That whole square, yes. Na? This you understand?
Yes.
Okay. Next, I need to calculate SP2. SP2 equal to 1.1. That means N1 cancel. N1 square into SP1. Na? SP1, no need to write the value. Only the how many times. This is very important. Very important. How many times or how many percentage. This is very, very important. Next, tell me the value quickly. 1.1 square. 1.1 square. Tell me the value quickly.
1.21.
1.21.
21 SP1, na? 1.21 SP1. Okay. That means how much percentage? Total percentage? 121%, na? Original value. It's a final value. 1.21 into 100. Then 121%. That means 21% increase. Now 121 means 100 plus 21. This you understand? Total 21%, total 121%. That means 21% increase. Final pressure. Can you imagine? Can you understand? Quickly tell me. Vikram, Nilesh, others. Quick
Yes, sir.
answer. Understand, na?
Yes.
Basic understand something. The formula. You have to understand the formula. Simple. They will not give the value. Already we have discussed. The speed is 1500. Basic. N1 is 1500. N2 going to increase 10%. That means 1500 into 1.1. That means plus 10%. 1650. Then what will happen? Pressure. How much value? That we have to calculate. Sometimes they give the value, sometimes they will not give the value. Only 10% increase, 10% decrease. Okay, next. Speed going to reduce 10%. Speed going to reduce 10% degrees. What will happen? Pressure. Always write it the formula. What is the static pressure formula? Simple, you write it n square. Then you can write it basic formula. This is basic formula. What is the formula? Quickly tell me. 10% degrees. Speed going to decrease 10%. What will happen? N1 going to reduce 10%. Write it formula. Quickly tell me formula.
SP2 divided by SP1.
Okay. SP2 divided by SP1. Okay, equal to
Equal to
N2 by N1 whole square.
N2 divided by N1 whole square.
Whole
Na?
square.
Okay. Now what is the criteria? Speed.
10%
One.
decrease is equal to 0.9.
Okay.
So
Speed
N2 will
10%.
be
N2 equal to 0.9 N1. Okay. N1 equal to N1. Na? This is original. Then whole square. Okay. Now tell me the value. N1 cancel. 0.9 square. What is the 0.9 square?
0.81.
What? 81. 0.81. 0.81. SP2 equal to SP1 divided by 0.81. 0.81 means 81%. Na?
81%.
Okay. SP2 equal to 0.81 times of SP1. This is you understood? SP2 equal to 0.81 times of SP2. Okay. That means 81%. How much percentage reduction? This is original. This is a final. This is a final pressure. Final pressure, how much reduction from original pressure? 100% is a pressure one. Then reduction is a 90%. Na? 100 minus 81. It's a 19%. Same. 100 plus 21. Na? Same. 121 means 21% increase. One is a increase, other side is a decrease. How much percentage reduce? 19%. Can you understand this one? Understand, na?
Yes.
Any doubt? Tell me. 100 minus 81. SP2 final pressure equal to 0.81 times of SP1. 0.81 times of. That means SP equal to 100%. Then 100 minus 81%. Then 19%. Very, very important. Next formula for power. Power. Okay. What is the equation related to power?
SP is
Power directly proportional to
N cube.
N cube. Okay. Now speed. Same 10% decrease. Write it formula. Quickly tell me the formula for me.
SP2 divided by
SP,
SP.
that SP means static pressure.
Static pressure.
Power. Power. Then now I am asking power. P2 divided by P1. N2 divided by N1. You understand this formula? N cube.
It is power, not SP. Okay.
Yes.
Mhm.
The speed going to degrees 10%. What is the value N2?
0.90
0.90
N1
N
N1 cube.
N1. Okay, N1 cube. Yes. Total cube. 0.9 cube.
Total.
Okay, N1. Then whole cube. Then what will N1 cancel? So 0.9 N cube. 0.9 cube. What is the value? You have to always fire mode. Always use the formula quickly. What is the value?
0.729.
729. 72973. Almost. Understand? This is percentage. Tell me the percentage. Next one, percentage. 73%. Understand?
Yes, sir.
P2 divided by P1 equal to 73%. Then P2 equal to 73% of P1. How much percentage reduce P2? How much
70%.
reduce?
17%.
27% reduce, na? That you have to click. 27% degrees. Okay, next you have to tell. Speed 10% increase. Okay, speed 10% increase. Tell me the value next one. Formula quickly tell me any one person. Vikram or Nilesh, anyone?
P2 by P1 is equal to N2 by N1 whole cube.
P2 equal to P1 equal to N2 divided by N1 whole cube. Value tell me. N2,
1.10 into N1 times.
N1 whole cube.
N1
Okay, very important.
whole
Whole cube. N1 cancel. 0.1 cube. What is the value?
1.331.
1.33.
331.
Okay, 1.33. What is the percentage? 133%.
133.
Okay, how much percentage increase power? How much percentage increase power?
33.
Power 2 divided by power 1. Okay, power 2 equal to 133% of power 1. That means 33% increase power. Very, very important. This you understand, na?
Yes, sir.
Okay, this understood?
Yes.
This is very, very important formula. Fan law. We always using for this 10 mark. You basically understand this formula, you can easily calculate. If you forget the cube, square, and equation, this simple formula, you have to remember each and every time you have to calculate.